discuss about the Biot-Savarts law. Before this, we discuss about magnetic field. Magnetic field is a vector quantity and it is denoted by B vector. Its unit is Tesla or Newton per ampere meter. In class 9th and 10th, we studied that if a magnetic compass is put near a magnet, then this magnetic compass deflects. The same thing we observed if we have a current carrying wire and we put a magnetic compass near this, then this magnetic compass deflects. So this current carrying wire is like a magnet. If we change the direction of this current carrying wire, then this magnetic compass deflects in that direction. So this current carrying wire produces a magnetic field around itself. If we put a charge near this current carrying wire and this charge is in rest, then we see that there is no force act on it by this current carrying wire. And if we give some motion to this charge, we give some velocity to this charge, then we see due to this current carrying wire, this charge q deflects from its path. This means that there is some force acts on this charge q. The force acts on this charge q due to the magnetic field. So current carrying wire produces a magnetic field around itself. Now we discuss the Biot-Savarts law. In this, T is silent. We have a current carrying wire and we want to find out the magnetic field at this point P. So Biot-Savarts says that from this whole length of this current carrying wire, we can't conclude the magnetic field at point P because the value of magnetic field changes due to this when the angle theta changes. So we take a small element dl, and due to this small element dl, we want to find out the magnetic field at this point P, that is dB. And the distance between dl and P is r vector and the angle between dl and P is theta. So this magnetic field dB is directly proportional to current I. That means when current increases, magnetic field increases. If the angle sine theta increases, then also magnetic field increases, and this magnetic field obeys the inverse square law. So dB is directly proportional to 1 by r square. If we decrease the distance, then magnetic field increases. And this magnetic field dB is directly proportional to dl, this element. So in vector form, we represent the magnetic field as dB vector is equals to mu naught upon may 4 pi I dl cross r by r cube. This is the vector form of the Biot-Savarts law. dl cross r is equals to dl r sine theta. So dB equals to mu naught upon may 4 pi I dl r sine theta by r cube. So in scalar form, we get dB equals to mu naught upon may 4 pi I dl sine theta by r square. This mu naught is permeability in free space, and the value for mu naught upon may 4 pi is 10 raised to power minus 7 Newton per ampere square, and mu r is the relative permeability. Mu is the permeability in medium and mu naught is the permeability in free space. This is the relation of relative permeability and permeability in medium and permeability in free space. Thank you.